A couple of firsts for India: the first gallium-nitride power transistor, and the world's first web-based tool to identify wheat varieties. Let's also talk about the wonders of artificial intelligence and machine learning. Want some spoilers for the surprise element in election results? Look no further than social media. Want to know which is the best policy to protect a forest? Machine learning has the answer. And would you like to make a pesticide that kills only a specific pest? You can use machine learning for that too. Well, maybe you and I can't do these things, but we can take a look at how these super smart scientists did it. I'm Annie, and this is Research Bytes, your dose of science news. Today, all our electronic devices have one or more parts with a semiconductor inside them. You can find semiconductors at the heart of a microprocessor chip and in a transistor too. Anything that's computerized or uses radio waves depends on semiconductors. Today, most semiconductor chips and transistors are created with silicon. You must have heard expressions like Silicon Valley and the silicon economy. And this is why silicon is at the heart of any electronic device. But recently, another semiconductor made out of gallium nitride is making its way into electronics. It's better suited for high frequency and power applications. Since gallium nitride technology is still taking its first baby steps, it wouldn't be quite as expensive to set up a foundry and start manufacturing it. This could be India's opportunity to set a mark in the niche field of making semiconductors. India's first ever gallium nitride power transistor works just as well as some of the transistors that are on the market today. A transistor acts like a switch or an electric amplifier in an electronic device. Gallium nitride transistors can operate at very high voltages. They switch on and off much faster and also take up less space than a silicon transistor inside an electronic. The researchers made the gallium nitride transistor a high electron mobility transistor. This means that it allows a lot of current to pass through it at a high voltage and won't break down if it's used in a power switching application. Why is this so cool? Because a high electron mobility transistor has a conducting channel between two terminals. They are called the source and the drain. Current passing through it is controlled by a third terminal called the gate. In this type of transistor, the channel is usually conducting or on, so that current can pass through it as soon as it is powered, and it needs a negative voltage at the gate to stop the flow of current. But this is a challenge. Imagine you plug in your mixer and it immediately starts spinning. Instant mess, right? So for a transistor to operate reliably in an electronic circuit, it needs to be in the off state when no voltage is applied and can be turned on by applying a voltage at the gate. Transistors use different techniques to keep themselves in the off state. But some of these methods affect the stability, performance, and reliability of the device. The solution is to use a gate that is doped with impurities that can deplete the electrons from the channels and switch it off. This essentially means that they could reset the channel, move the gates closer inside the channel to restrict the flow of energy and create a smaller channel. The challenge here is that the gate and the channel form something called a diode, a device that blocks current in one direction while letting current flow in another direction. It starts to conduct current when a voltage higher than a certain value is applied at the gate, and this makes it unusable. This is exactly like a school gate at dismissal time. The gate needs to stay closed so that the little children don't run out into the streets. And who better to man this gate than the dutiful security guard? The security guard in this transistor was a gate made out of aluminium titanium oxide. The gallium nitride transistors with a titanium oxide gate are in the off state by default and work like any other common transistor. The scientists picked titanium oxide because it leaked the least amount of current and provided a better control of the voltage that's needed to turn the transistor on. These transistors have a better performance and power handling capacity than similar devices that are on the market today. The team of scientists that developed this technology are now in talks with the government of India to set up a commercial gallium nitride semiconductor foundry with an initial investment of about 3,000 crore rupees. Around 11,000 years ago, farmers in the Fertile Crescent of the Middle East had to tackle a unique challenge to grow wheat. Once the wild grain ripened, it would scatter onto the ground well before it could be harvested, with even a gentle nudge from the wind. To save their precious golden grain, farmers chose and bred a plant that could hold ripened grains until harvest, and they also bred plants that gave them bigger grains with better yields. A couple millennium of selectively breeding crops like wheat, rice, and maize has given us so many different varieties that better suit our needs. So, how do we differentiate between the different varieties? Plant breeders typically identify new varieties by just looking at their external features. But often, the differences are subtle, and two varieties can be almost indistinct. Misidentifying a variety can mean both economic and legal hassle. Recently, PepsiCo, the company that manufactures the popular brand of potato chips, Lay's, tried to sue a group of potato farmers from Gujarat over the variety of potatoes that they were growing. And this is why a fast and reliable way to identify different varieties is the need of the hour. And researchers have developed a way to do just that for wheat. It uses a mix of software engineering and mobile application development and genetic analysis. The web-based server called Vista is the first ever plant variety identification system in the world to identify wheat varieties. It is important in developing and improving the existing breeds, tracing the crops to its breeder or its geographical location, and even settling legal disputes. In India, the Protection of Plant Varieties and Farmers' Rights Authority recognizes new varieties of crops by growing its seeds and looking for unique traits. A new variety has distinct morphological or physiological characteristics, like the height of the plant or the color of the leaves. They set it apart from other reported varieties. The Protection of Plant Varieties and Farmers' Rights Authority also checks that the features of the new variety are uniform across generations and that they remain unchanged and stable. These features are called the distinct, uniform, and stability features. The researchers use these features and 54 DNA variations to generate a unique identifier in the form of a quick response, a QR code for each type of crop. And although the current study is limited to Indian wheat, it can be easily developed to include other crop types as well. The results of this analysis are stored on a web server named Vista. This stands for Variety Identification System of Triticum aestivum, and Triticum aestivum is our Indian wheat. It acts as an easily accessible database of crop varieties that are linked to their genetic markers. It's the year 2019, and a little while ago, the general elections were in full swing across India, as the world's largest democracy engaged in some fierce poll banter. Although opinion and exit polls spell out their prophecies, there is an element of surprise that shakes up the masses and the markets. With the advent of social media, political parties have redesigned their election campaigns and devised strategies to reach their intended audiences better. So, could social media then hold the clues to the results of the elections? A recently published study says yes. Researchers designed a model based on the social networks of online and offline voters. They made reliable predictions on the surprise element of election results and suggested possibilities to decrease it. This surprise is a phenomenon only of closely contested elections. The element of surprise, from the voter's point of view, is the scenario when the voter's expected candidate does not win. The study focuses on predicting the surprise of a given voter who is embedded in a social network and perceives the winner through their interactions with their connections in their social network. The researchers tested their model using the data from the UK-EU referendum, which is popularly known as Brexit. They used the 2016 referendum, when the UK voted to leave the European Union. It was a closely contested election with only two outcomes: leave or remain. The mandate to leave came as a shock and a surprise for the entire world. On the flip side, if the margin of victory of one person or party winning over another is massive, there will be less surprise at the outcome, because the voters would have expected this result despite small errors in their estimated bias. So, if the global conditions for an unsurprising election outcome actually hold in an election, and you are a good estimator of your own political biases, then your local observations, say your friends' voting patterns, could tell you a lot about who could be the winner in these elections. There may be some amount of surprise if the voters are not good estimators of their biases and the election is a close contest. And while it is tempting to try and predict the results of an election beforehand, it is almost impossible to predict such a thing without carrying out a lot of sampling and normalizing statistically, which in itself is much more expensive and an exhausting process. So, in the meantime, I guess we'll just have to wait for the results with everybody else. Have you watched the movie Her? It's a movie about a virtual assistant that learns about you and becomes more personalized over time. It's a very interesting concept that draws on how artificial intelligence and machine learning work in our daily lives. You've probably also noticed how YouTube and other online platforms give you more personalized recommendations, right? This is similar to that. Artificial intelligence tells an automated system to accomplish an end goal without explicitly telling them how to get there. Isn't that fascinating? The system is fed with data and scenarios and allowed to improve on its own with time. Artificial intelligence and machine learning are techniques that let your data do all the work rather than having a person sit down and tell the system how to get something done for the different scenarios that it could encounter. Plus, it can make decisions the way a person would, as if they were actually sitting there and were able to process all that information. This kind of software programming can make a big impact in our day-to-day lives. For example, for the first time ever, a study used algorithms based on machine learning to evaluate the forest management policies in Himachal Pradesh, India. Let's talk about how they did that. In India, there are different forest management policies in place to protect and promote the sustainable use of forest resources. But how well do such management policies work? The first policy, called the Cooperative Forest Management Policy, involves the formation of a federation of forest cooperatives with financial and technical support from the state government. The second, which is called the Joint Forest Management Policy, is made of communities that are involved in forest regeneration and protection. The researchers started with the hypothesis that joint forest management policies will be less conducive to the vegetation growth in the long run when compared to cooperative forest management. They then measured the vegetation growth in the forests of the Himalayas that are managed according to either of the two policies. The results showed that neither joint forest management nor cooperative forest management affects vegetation growth in the long term. This tells us that future community-based plantation programs in the Indian Himalayas would do really well to provide alternative grazing options to forest communities and to secure the rights over our forests and foster a positive long-term vegetation growth trajectory. And this is just one application of machine learning. The possibilities are endless. In another study using machine learning, researchers developed insect-specific pesticides. This could be an amazing way to save important pollinators like bees from going extinct. The researchers developed a computer-based tool called NeuroPython that can help make new neuropeptides that are specific to certain insects. Neuropeptides are made out of about 5 to 80 amino acids. They control a variety of biological activities like growth, development, and metabolism. They also influence behavioral activities like mating, migration, and egg laying. Any disruption in the amino acid sequence of a neuropeptide can kill the insect. So creating a variety of neuropeptides could be an effective tool to design insect-specific insecticides with mutant neuropeptides. This web-based tool takes the amino acid composition of the insect neuropeptides as input from another web-based database called DINA, or the Database for Insect Neuropeptide Research. It then learns any possible new sequences and predicts whether a given peptide is an insect neuropeptide or not. It can also differentiate between insect neuropeptides and human neuropeptides. This is important because we don't want those insecticides affecting us. Plus, since neuropeptides are organic chemicals, they are environmentally friendly. They don't leave behind any toxic residue. So machine learning seems to be our yellow brick road. Teaching our machines to solve our problems could help us come up with extremely useful inventions. But let's just hope that our machines don't teach themselves how to be sentient. We may not be ready for that just yet. Thank you for listening. Links to all my references are in the description below. I hope you enjoyed this podcast. For more science-based stories, podcasts, and news, log on to our website www.researchmatters.in.